Hello, everybody. Welcome to today's session. On today's session, we have Mr. Ian. He's back with us again. Today, he's here to take us through Windows and Linux exploitation. So please pay all your attention to him, and he's going to give us what he knows about this topic. So, Mr. Ian, welcome. The floor is yours.
Thank you so much, Karim. I appreciate for the warm welcome. So hello guys, today we are going to be handling Windows exploitation. Basically, last time we looked at introduction to web application exploitation. So it's going to be a bit of extension on Windows web app exploitation, but we are going to mainly touch on both exploiting a web application, gaining a foothold, then probably performing a privilege escalation using some various techniques. Also, for this specific machine, I've incorporated some Python coding. So you're just going to see some bit of Python coding that you're going to be doing to perform privilege escalation, and some bit of using C2 command and control frameworks whenever you're trying to exploit Windows machine. It also applies on Linux, but today we're going to be testing on Windows machines. So I hope you're going to enjoy the machine. It's a really nice one. And let me now start by sharing my screen so that you can actually see. So once my screen is visible, you can just give me a feedback, Karim, then we can continue.
Yeah, we can see your screen.
Sweet. Thank you so much for that. So today, the box that we are going to be handling, it's going to be called DVR. It's one of the machines in offensive security labs, the proving grounds practice. So it's a machine I saw from the, I can't share exactly the screen for OSCP because it's in a different screen, but the offensive security team rated it as an intermediate box. So basically it's not an easy box, but you're going to see through the walkthrough that, you know, it's just a matter of exactly how you're performing enumeration. So the community rated it as hard. I don't know exactly why, but you know, we're going to see, and depending on exactly how you're going to see it, maybe you can just have your own feedback on exactly, you know, if it's an easy or a medium box. So first thing that I did is I connected to the VPN. This is my VPN for OSCP or offensive security. Offensive security, the platform itself. So the next thing that I did was, you know, after getting the IP address, which in my case it's supposed to be this one, let me just copy it. We are supposed to do a ping scan to see if the host is actually alive. So basically, you know, I think I mentioned before, if I didn't, if you're trying to, you know, identify the operating system or machine, a TTL will actually help you. If you see something that is less than 64, probably you're dealing with a Linux box. If you see something that is less than 128, it, you know, these TTLs decrement depending on the number of hops. So basically it can either be 128, 127, 126. Like in our case, it's 126. So basically it's indicating that first of all, you're actually dealing with a Windows box. Then if it's something like 250 or something lower than that, it can be a network routing device. But in our case, we actually, you know, trying to exploit a Windows box. So the next thing that you're going to try to do is to perform an Nmap scan. Basically, I said before, an Nmap scan is trying to identify the services that are running on that specific box. You can't exploit something that is not running. So what you're doing is trying to send a packet to each and every port that that specific system has. Then from there, you know, if we receive a feedback that, you know, the port is open, then we try to do a service enumeration, script scans, trying to identify the exact services that are running on this specific box. So basically, that's where Nmap comes in. You know, you can't just run in blindly and start throwing exploits on a box and hoping for the best that you're actually going to get the exploit to work. You need to, you know, do something in a calculated manner, so to say. So to run an Nmap scan on this box, you're just going to do Nmap to specify the binary that you're going to run, then specify -sc to tell it to run safe scripts, then -sv to tell it to do service enumeration. Then after that, you're going to be specifying the IP address. In our case, it's supposed to be 192.168.220 and 179. But the thing is, I've already run this because I did this box like a week or 2 weeks ago. So let's just look at the Nmap scan. Then from there, try to identify exactly what's running. Then you can try to see exactly, you know, is there something that you can actually exploit that's running on this box? So number one, we get that port 82 is running, it's running SSH. Remember, SSH is just a way in which you can actually access a machine if you have the required credentials. But you can see we even have the version of Bitwise Win SSHD that is running. So the next thing that you can actually do is to come here, then go to Mozilla, then try to see if it has a specific exploit, because sometimes these softwares can actually have exploits. So it's something that you can actually look into, try to see, is there an exploit that I can try to use on this specific box to get either remote code execution or find a way to further exploit the box. I'm actually not going to let this finish because I know there's no exploit. But the thing is, this is one of the main services that you can actually check to see if it has an exploit. The next thing is port 135 and 139. To enumerate them is really simple. So what I'm going to do is to come back to my Linux box. Then I'm going to run a tool called enum for Linux. Basically, it just runs regular enumeration on port 135 and 139. Sometimes it's possible to identify users, so I'm specifying -A to tell you that I want you to do all simple enumeration. As you can see here it is. Then you specify the IP address, which is this one, then try to run it. So you're going to leave that to run in the background. Then you're going to look at the results later on. So the next port is this one, port 445. Basically, it's saying that it might be Microsoft DS, which means SMB. So we can try to check if SMB works. To check it is not hard. We're just going to be using a tool called crackmap.exec. Specify the protocol, which is SMB. Specify the IP address of the system. Then the next thing, we're going to try to log in using guest authentication. So you specify guest, don't specify a password, then dash to see if you're going to make it to work. So let's just give it a second and hope we get something, either an access denied. So it says that this specific Windows system, the guest account has been disabled. So let me try to log in using something like an anonymous authentication. Like, let me use anonymous. So you can use any word like test to see if guest authentication is enabled. Still, can I use something like an anonymous authentication to just access the site? So it gives you a failure message, meaning for us to be able to access this SMB share, what we need is we need to have appropriate credentials. So that appears to be some sort of a dead end. Another thing, if we go back, we can see that the server doesn't even allow that anonymous authentication. So, crackmap.exec told us that we can't be able to perform anonymous authentication, and enum for Linux did the same thing. But being able to perform these enumerations automatically, it's actually a good idea, but take it with a grain of salt. Reason was as to why I'm saying this is because there was a time I was doing some box, then enum for Linux told me that you can't log in with anonymous authentication, and it turned out to be a false negative. So basically, if I had done the enumeration manually, it's something that I could have identified that it is actually possible. So let's just check using RPC client to see if this is actually the case, and I'm going to specify -u, then tell it that I don't want to specify a username, then -n tells RPC client that I want to use anonymous authentication, then try to access. It gives me a status access denied, meaning null authentication doesn't work. Let me try without any credential. It says that login failure. Let me try with guest. So basically, these are just the type of enumeration that you're always going to be doing whenever you're trying to access these sites. So basically, all of them didn't work, meaning we were not able to, find any authentication that actually worked on the system. It doesn't mean it's a bad idea. It's actually a good thing, but it means that maybe our effort should be spent elsewhere. So if you go back to the nmap scan, then the next thing that you're going to do is to look at port 8080. That seems to be some sort of a website. The reason as to why I'm saying that is because if you look at the fingerprint screen, you can notice that it has some sort of headers that indicate that this might be an HTTP application, like HTTP version 1.1. Then it tells you 200. Okay. So let me just pick the IP address once more. Then what you're going to do is to try to navigate to that site using port 8080 using Mozilla. Then we get, let me just increase the font because I'm sure nobody's actually seeing exactly. I think that's better.
Yes,
so
it's better.
The site tells us it's called Angus surveillance. So basically, the next thing that you can try to do is to Google Angus surveillance to see if it has some sort of a vulnerability. So Angus, let me make sure I get the spelling correct. So Angus surveillance. So there it is. Then let me just Google something like an exploit. So basically, this is the thing that I'm going to be using, and we get that there are. So I can see that there are two vulnerabilities that the application has. One of them is weak password encryption. So let's just look at it. The exploit is already in exploit.db, and it says that Angus surveillance configuration is present on this. Then probably it says that whatever you're trying to attack is a weak password encryption. So basically there's some sort of a password, but as we speak right now, there is no even password that we have for the box. So this is something that we can keep in the back burner in case, we get some password or hash. As you can see, what he did is he provide a hash here. So if you either get a password or a hash, it's something that we can actually look at. Then we can look at this one. It says Angus, also the same version of the software. Remember, it was version 4.0 also here. If you are trying to understand exactly where I got it, here it is. It says that it's Angus surveillance version 4.0. The same exploit is seen here, Angus version 4.0. It has something known as a directory traversal. So basically, this is the payload that was given. Let's just try to take this payload, then go back to Angus, then just try to intercept a request using Babsuit, because I talked about Babsuit before, so I'm sure you might be a little bit conversant with Babsuit. Then try to specify the payload that has been provided in Exploit.db and see if it's going to work. So let me just forward that request, then go back to Exploit.db, take the exploit that was provided before, then try to run it and see if it's going to work. Then we can start from there. So there it is. Let's run it and see what you're going to get. This is exactly what we get. And what is happening is if I go back to the exploit.db, it says that this is the results that you're going to get if the exploit worked. So as you can see from our output, we see that it's the same exact thing. So it means that, whatever we got and whatever has been given on exploit.db, it seems to be similar, meaning our exploit probably worked. But the fact that we're able to extract Windows system.ini, it doesn't necessarily mean we've been able to compromise the box. So the next thing that we're going to do is, first of all, before continuing with the exploit, let's just run both a Go Buster, then probably a Nictoscan. Remember, I said before, background enumeration, these are just enumeration that you run, hoping that it might find something. But it's something that it's just, let me say, a shot in the dark. So it might find something, it might not find something. So if you try to run Go Buster, then dir-u specify the URL of the box, then -w to specify desktop, then specify, that is the word list, then git seclist, then discovery, web content, then draft, small words.txt. Then the next thing that we need to specify an extension, -txt, HTML, then probably anything else. Let me just specify those. Then specify threads 30. Then let's see if it's going to work. So we get an error saying that the server returns status code that matches the provided options for non-existent URL. So, what Babsuit, not even Babsuit, but GoBus is trying to tell you is that if I try to provide a non-existent URL, I'm still getting a 200, okay? So there's no way to filter out if the request is not valid. Remember, by default, what GoBuster does is it uses the status code of 404 to identify if a URL is either correct or not. So to demonstrate this, if I go back to Babsuit, then just send the request to a new tab, because we just need to keep that one in the background. Then the next thing that I'm going to do is to try to say like musyoka.html. Remember, this is not supposed to exist on the server. So let me try to see if that's the case. Remember, I didn't do this before. I know exactly how to circumnavigate it, but as you can see, the server returns at 200. Okay, should I, Karim, maybe you can just pick, should I increase the font?
Yes, please. It will be much better.
I felt like the font might have been a little bit too small. Let me increase it again to be something like 28.
Yeah,
Then
perfect.
a little bit visible. So as you can see right now, if I specify a URL that does not exist, what the server does is still it returns a 200. Okay, this makes GoBuster to say that I can't actually be able to run a brute force scan, because whatever I'm being provided with and whatever the server is returning, it still returns a 200. Okay, for something that shouldn't actually exist on the server. So this is where I say that you need to have a different varieties of tools to do the same exact thing. Like, the fact that GoBuster has failed, and I know if we try to debug, we can try to include other status codes and see if it's going to work, but I don't want to go down that route of debugging. There's a tool called FAF. FAF is just another way of performing this same enumeration. So let me go back up, pick my syntax, or let me say the syntax that I used before, which is this one, because trust me, the syntax between FAF and GoBuster, doesn't change that much. So what I'm going to do is I'm going to use that syntax, then just do -h, because I'm not exactly sure if -x is to specify extension as GoBuster did. Let me just check. I think it's -e, not -x. So here it is. If you look at -e, it says that it's comma separated list of extensions. So if you want to specify extension, you don't use -x, you just use a -e. Then I'm going to specify .txt, then .html. So I'm going to let that run, then we're going to see exactly what you're going to get. It tells us that, it gives us an error, and the error is because for FAF to work, you need to specify exactly where you want to do the fuzzing. So to specify where you want to perform the fuzz, you just use a fuzz in capital letters, then you're going to tell it, whatever input I've provided, use it in that specific place on the URL. So let's try to run it. We get a lot of things, and it shows us that, still it's 200. Okay, that's number one. Number two, the size is the same, the word is the same, then the lines are the same. So basically, the best thing about using FAF is that we can actually use either the size to filter out whatever content we want to get from the size. We can use the words, we can use lines. So what I'm going to tell FAF is I want you to filter out by using -fs to filter out anything, let me not even use size, let me use words to filter any words that are 12 characters, because it means that probably it's a false positive. So what I'm telling you is that if you get a page that has 12 words, just filter it out, because it's not the correct length of whatever we want to get. So if I do FW, then specify 12, then hit enter, we see that the false positive actually have, decreased. So right now we have, pages like stats.html, we have help.html, we have tools.html. So let's try to see if start.html actually exists. Remember, if it doesn't exist, you're going to get this message whereby it says file not found. So let me just copy that, come back here, then try to access stats. You can see we don't get that file not found. So basically it means this one exists. So that's a way that you can actually identify if a file or a folder exists. So it's something that, I think not even I think, I've seen this happen whereby it's like directory just decides to throw off any offensive security tools, because, everything returns at 200. Okay, so understanding how different tools works, it will actually help you whenever you meet such a situation in your case. So while that is running, let's also run NictoScan. Remember, before I said NictoScan is actually supposed to do a vulnerability scan on a site. So to run NictoScan is not hard. It's actually really simple. So let me just go to a new pen, then do a NictoScan. NictoScan, then specify a -h, then specify the IP address of the system, which is that one. Then NictoScan is also running in the background, which is okay. So while these are running, what we can do is, remember we found directory traversal. Basically, by directory traversal, what I mean is we can be able to read files that are outside the web directory. So what we can do next is come back here. Let me just switch off the BAP proxy tool. Then what we can try to do is to Google something like, what can I say, LFI. LFI and directory traversal are the same. The only difference comes in when you can actually change it to get a remote code execution. So for directory traversal, you can't get a remote code execution, but for a local file inclusion, it's possible to get a remote code execution. So let me Google LFI, then word list, Windows GitHub. So there it is. We have some sort of a word list for Windows, and you know what I'm trying to look for is, are there any files that I can get from the system? So most of these files are going to be false. Let me increase the font because I'm even sure you're not exactly seeing what I'm saying, but you know, there are files that are more important to me right now. I could have looked for XMPP files if I knew that the server was actually running PHP. It's actually not running PHP, so I'm not going to go down that route of actually looking for PHP files. So let me try to see if there are any files that can be interesting to us. Like, let me see if you can include file like a boot.ini. So let's go back to our site, take this, send it to another repeater tab, and instead of looking for something in Windows, let's just try to see if boot.ini exists. So let me paste that there, then try to access it, and we get that the file is not found, which is okay. So that file does not exist. There is a file that I'm looking for, but I can't see it here. I don't know exactly why. It's called SAM and system. So basically what happens is, for Windows, it has some registry called SAM and system. If you can actually use directory traversal to extract these files, you can actually dump the hashes for that specific system, then either try to do a pass the hash attack, or you can actually try to crack those NTLM hashes to see if you can actually log into any service. I can't see that right now, but it's something that, you know, given the fact that I've relayed that information, you can actually go and look for it, because trust me, if you can be able to find the SAM using directory traversal, you can actually be able to compromise the system entirely. It's something that I've seen it happen, but you can actually go and check it for yourself. I can't do everything right now because of time constraints, and I think I have a lot to cover right now. So I'm just going to cover something that I know it is actually going to be. Like in our case, we have this file called users.html. So let me try to access the users.html to see exactly what you're going to get. So let me go back here. Then I'm going to try to access users.html. So there it is. There it is. So we get that this system has two users. One of them is called viewer. Another one is called administrator. So these are the two users that this system has. And remember, if we go back to our nmap scan, so let's just go back. We had an SSH that was open on this specific box. So what does that tell us? That these users might probably be having something known as an SSH private key. So if you can actually access those SSH private key, we can have the functionality of being able to log into that system. So to check that, remember we already had directory traversal. So let's just try to check it and see if it's going to work. Remember that user called viewer. So what you're going to do is to go to users, then %2f, then viewer, viewer, then %2f, then .ssh, then %2f, then id underscore rsa. So most of the time, whenever users are generating keys, it's actually by default, it's actually stored in this directory.ssh. Then by this name, it can either be, it can have specific default usernames, but it's something that you can actually check online to find the exact. There are like 5 or 6 default usernames that these keys might have, depending on the exact encryption that you're actually trying to use. So let's try to access it and see if it's going to work. And voila, we actually have a key for the user viewer. So with this key, we can actually most likely try to log in and see if it's going to work, because remember we had SSH already available on this specific system. So let me save it in a file called SSH. I messed up that file name. So let me just log out, then include SSH, then include the file. Here it is. Then do a chmod. No, even before doing that, let me just try to SSH using that key as it is. So SSH does try SSH, then viewer at, then specify the IP address of the system. Let me get it from my second screen. Here it is. Then let's try to log in and see if it's going to work. So we get an error saying it's required that this private key is not accessible to others. So you know, right now it says that our private key is unprotected. That's why we can't actually log in using that key. So if I do ls-la ssh, then we look at it, you know, we have both, you know, our user has read-write privileges, as you can see, read-write, then read. Our group has read privileges, but also these one present others, and others have read privileges. So what the application is actually telling us, we need to ensure that this private key can only be accessed by us, and you can actually change the permission using chmod. So chmod, then 600, then specify SSH as the key. Then we can actually try to log in again. Also, if I do an LSLA right now, you can see that we are the only person that has read and write privileges. So no other group or users have the same rights as us. So basically it means we are the only person that can actually access this private key. That's the way you can actually protect it. So if you try to do an SSH right now, you can see, let's wait and hope it works. It doesn't work. And these are some of the, let me say, hurdles of, roadblocks that you can actually get on pen testing. It says that tried using a different terminal environment to log in. So the first time that I was actually doing this box, I hadn't received such an error message before. So what I did was I just took the error message, went back to, logging to Mozilla, then Google pasted that, then included SSH. So we get these first forum. Then it says that if you want, you can actually try to use term is equals to screen, then specify the SSH command that you're trying to run. So let's try to do that and see if it's going to work. So term equals screen, then specify the command, then try to log in again, and it works. We've actually been able to log in into the system. So that's how you're supposed to exploit that web app. Get directory traversal, then make 1 and 2 connections, and identify that you had the ability to actually log into that system. Then get the SSH private key, then log into the system. So if you go to the users home directory, you can actually see there is approved.txt local.txt flag. So if I do type local.txt, you can actually see that it works. So we can actually submit this as a flag for that specific system. But right now, as you see, we only have user. What we want to get is admin or anti-authority system privileges on this specific box. And to do that is actually not hard. But let's dial down a bit first of all. So we've been able to get the local.txt flag, but what we need now to do is, as I said before, privilege escalation. Basically, what that means is trying to escalate our privileges from a normal user to become an admin of the system. Because right now, as we speak, we actually, let me just put the word like we are restricted. So there's not much we can do, basically, because we don't have admin functionalities on this side. So what you're going to do is to try to see, are there any misconfigurations that you can actually exploit to be able to gain administrative access to this specific box, or let me say server or site, depending on exactly how you want to look at it. But what we can do is, first of all, dial down a bit. Remember, initially when we were trying to have the introduction, I said that there was something known as a C2 framework. So for a C2 framework, it's just a command and control, and basically most hackers, both ethical and unethical, let me say black hats and white hats, most of the time they use something known as a C2, a command and control framework, to be able to get shares. So it's rare to find somebody using Netcat, or even using, maybe, let me say Netcat, not even SSH, Netcat most of the times, because those sessions are actually easily caught. So what I can do is, first of all, let's try to get a remote code execution through a C2 framework. Then you're going to be doing some sort of enumeration, then lastly exploitation to get admin access on the system. So for my case, as you can see, far finished out, it got some files, but we've been able to exploit this site. So I don't feel like there's much disease that you can actually look at from that site. But remember, as I've said, that's exactly how FAF works. It works the same as GoBuster, just based on different parameters. Also, Nictoscan finished. It said that there were no errors reported. 2 items were reported. It says that it misses a meta. So basically, whenever you're doing, let me say, a pen test, you'll include these as low findings, probably low findings, telling them that it's just additional measures to ensure that your site is secure. It says that no CGIs are found, but it didn't give us anything interesting. But I want to tell you something. Remember to always run Nictoscan. I've been able to identify critical vulnerabilities that I could have missed personally if I was actually doing manual enumeration. One of them is shell shock. It's a vulnerability that was identified in 2015, if I'm not wrong. Don't quote me on that. But it's a vulnerability that if you can actually identify and exploit, you can actually get remote code execution on the system. So it's something that Nicto will always find out. So it's something that I believe you can run it in the background. If it finds something, well and good. If it doesn't find something, still it's well and good. But what I said is I want us to get a command and control. And right now as we speak, Sliver, I'm going to be using a C2 called Sliver. It's one of the best frameworks out there. There's no lie about that. So if you want to get Sliver, you can actually, let me go to my, we finished up with this page. We already have a necessary session, but let me just leave it in case we'll actually need it. So let's try to search Sliver, then specify GitHub, so this is the C2 framework that I'm using. So I only downloaded the app image. It's much simpler as compared to downloading the source code and compiling it yourself. As you can see, it has more than 5,000 stars. So basically, it's one of the most advanced frameworks that it's open source and it's free as compared to Cobalt Strike. Remember, for Cobalt Strike, if you want to pay for it, I think a single license goes for 400,000 Kenya shillings right now as we speak. Don't quote me on that. Go do your research. But the last time I checked, that is what was happening. So if you go to releases, if you want to download them, just go to releases. Let's give it a second. Then a new update was released yesterday. I already have it, but you need to download these files: the Sliver client, then Sliver server. These are the two files that you need to download them. Then after downloading them, you'll get something like this. Remember, I already have, this is the Sliver server. What we need to do, it works in a principle of a client server basis. So let me also get the client and see if it's going to work. We get an error saying that no config files are found. So basically we need to generate a config file. So let's generate a config file using the command new operator. So let me just get the exact details using -h. So it requires us to provide an lhost. So let me provide an lhost, then do an ifconfig, then turn 0 to specify it as my lhost. So here it is. Then specify --name to call the config musyoka.config, which is my name. Then lastly, let's specify not even --name, which is equals to Musyoka. Then to save the config now, I'm going to be using the name musyoka.config. So it says it already exists. Let me do a rm musyoka.config, then try to generate it again. And it says that the new configuration was generated successfully. So the next thing that I'm going to do is to come back to my client, then specify sliver-client, then specify import to import musyoka.config, which is the config file that we earlier generated. And it says that the new config file has been saved successfully. So I'm going to specify the command multiplayer so that I can actually log in from the Sliver client. So that is how you connect to it via Sliver client. Then the next thing that you're going to do is to generate a beacon. Basically, a beacon is like, let me say, a malware that is going to give us some sort of an interaction between the server and the client. So to do that, I'm going to be using the command generate, then -h to get the exact details that I want to use. So I want to generate a beacon, as you can see down here it is. Then I need to specify --mtls to tell it that I need an MTLS connection. Then let me get again my IP address for the system. Here it is. Then specify -mtls, then specify -os, which is going to be Windows. Then specify arc for architecture. Let me say AMD64. Then it's going to be 1, 2, 3, I think 4. That looks okay. So let's generate the beacon. Here it is. Then while it generates, we need to specify how we are going to get to that malware, which I think, let me not use SMB share because it takes a while to load the malware because it's almost 12 bytes long. So we're just going to download it to the system, then execute, then get a beacon on the system. So let's just give it about 20 to 30 seconds to generate a beacon or an implant. Basically, they call it an implant, but it's either implant, beacon, backdoor, whatever you want to call it. So it just gives you some sort of reverse shell. Let me say a connectionless reverse shell. But let's just give it a second because it's just compiling an exe that we can actually upload to the system. So here it is. It's called only tremor.exe. So this is the beacon that we need to upload to the system. And to do that, it's really simple. I'm just going to specify ifconfig because I can't remember my IP address for the love of God. Then specify python 3 -m http.server to just create a simple HTTP server that you can actually use for downloads and uploads. Server, I think I specified it wrongly. So we've been able to create an HTTP server. So let's go back to the Windows box. So here it is. Then just to PowerShell, then specify wget, then specify -o for that, because this is going to be our binary. And I'm doing this because I don't want to go back and copy pasting the same exact thing again. So I'm just going to go back, get the IP address for the system. So here it is. Then specify that IP address followed by the port, which is 8000, then followed by a slash. It's going to download the exploit for this box. As you can see here, it's actually downloading right now as we speak. So let's just give it a second. And in the meantime, let me clear my background to make things a bit more visible. Then you can just try to look at it once it finishes the downloads. I think this is better because it makes the connection a bit more stable as compared to me, doing a UNC path, then executing the exploit from the box. It could have been better if I was trying to evade antiviruses, but I'm actually not doing that. So if I do a dir dash right now, you can actually see that we've been able to upload the binary on the box. So the next thing that I'm going to do is to go to my Sliver server, then specify MTLS to tell you that. So basically what MTLS does is to tell you that I need you to listen to any incoming MTLS connection. Remember, for a binary we generated using MTLS. So it's like I'm just creating a netcat listener right now on my box. Then the last thing that we're going to do is to specify the binary, which is this one, only tremor, then execute it. Then specify and at the end to background the entire process. So there it is. So if I go right now to my client, you already have a beacon, from that box. So if I do beacons right now, you can see I have a beacon for the user viewer on this specific box. This is the IP address. This is the name of the beacon. Then the next second time is going to be in 1 minute 18 seconds. So let me try to interact with the beacon. There it is. Then I'm going to specify the command interact to tell you that I need to get an interactive shell. So we're going to give it a minute because beacons, how they work is they what happens most of the time is it tries to reaches back to my server to see if there's any task that it's going to run. Like in our case, we've created a task and tell it that the next time you check into my box, I want you to run these interactive tasks. So it's going to run that task the next time it checks in. So what it does is it goes back to this to my C2 framework, checks if there are no tasks, it sleeps for another 1 second, then comes back to see if there's another task. It's a bit more OPSEC safe, but in our case, it's going to take a long time if you're going to be running one command every minute. That's why I want to get an interactive shell on that system. So if you get an like as you can see right now, we have a session. So basically, beacons run tasks. Session gives you some sort of a shell. So right now, if I do use, sorry about that, then specify this one. You can see for sessions it's red, for beacons it's blue, and if I type something like an ls right now, you can see I'm able to execute commands on that system. So if I do ls then // I think it will work. Yes, we can actually execute commands on that system. So to be able to perform previous disconnection, the first thing that I'm going to do is to run something known as WinPeace. Basically, WinPeace just runs basic Windows probably misconfigurations checks on that system to see if there's a way that you can actually get remote code execution, or let me say a misconfiguration that you can actually exploit to become an admin on that system. So to run WinPeace, first of all, we need to upload it, and this is where C2 comes in. Instead of creating shares, mounting shares to be able to do uploads and downloads, I can just use this C2 to be able to do those uploads and downloads. So let me just create a new tab, then cp to desktop, git sharp collection, then specify .NET version 4.7 64-bit, then winpiece.exe to copy it here. So here it is. So I've copied WinPeace to my current working directory. Then the next that I'm going to do is to exit this one, then say upload winpiece.exe. So it's going to upload WinPeace to that box. So let's just give it a second. It's not going to take that long because the binary is actually really small. So let's give it a second and hope it finishes. Then what you're going to do is while you wait for it to finish, it should have actually finished by now, I think. Okay, it's taking much longer than I could have anticipated, but let's hope it works. I just hope the connection didn't drop. Then, okay, it seems like my connection must have dropped because I can't even execute commands on this specific system right now as we speak. Okay, let me see. It seems like my connection dropped. Sometimes it happens for these offensive security labs. So let me just confirm in my second screen to see if the lab is actually still running. I hope it is. But give me like 10 seconds to just confirm all that. It's well, the browser is refreshing. Yeah, I think I lost my connection. From how things are looking, it seems like I lost my connection. Okay, let me see. Yeah, I actually lost my connection. So let me just reboot the box again. Not even reboot, but start the box. So I think what happens is after every hour, what it does is it closes the box, then you have to restart it again. I think. I can't be sure. Don't quote me on that, but I think that's what happened. But it's really not that hard to get another shell on the system. It's actually really simple. So let's just give it a second. I've received another IP address of 192.168.194.179. So what I can do is, okay, I seem to have lost the connection. Okay, let me run it again. So there it is. Let me see if the box is still up. Just give me a second. Sorry about this. It's something that happens. It's something that you can never anticipate, but it actually happens. But don't worry. It's like the remaining portion of what we are trying to do is really simple, and it's going to take us less than 10 minutes to finish it, including the coding part, because trust me, coding is one of the simple things you can actually do whenever you're trying to do these boxes. So coding is not that hard or big of a deal. So let me just get the box again and see if I can actually ping it. I still have the IP address. So let me ping it and see if it's going to work. Yes, I can access it right now. Let me try to access Liver Client. It works. Let me see if my beacon is still alive. So you can see my beacon is dead. It means that, we need to do the entire process again, of which it's still okay. So let's try to first of all log in via SSH like we did last time. You can see the IP address change. So basically I need to use this new IP address. So let me put in the new IP address. Then let's try to SSH in as we did before. Let me put a yes and hope it works. So there it is, it worked. So if I cd desktop, then do ls doesn't work because I'm using cmd.exe. So let's upload the binary again. It's not going to be a big of a deal because remember we did it before. We just need to copy this command once again, then run it. So here it is. While it's trying to upload the binary a second time, let me clear my sessions. So let me see, are there any sessions? There are none. So if I do beacons, there is one beacon. So let me do a beacon-k to kill it, then specify the ID, which is here. It says that the beacon was killed. Then let me do a beacon rm to remove any unused beacons. And if I do beacons right now, it says that there are no beacons on that system. So let's get another shell again. So let's give it a second. And let me hope my connection hasn't dropped once again. Because if it has, we need to get rid of that C2 and try to do things manually, because I don't think we can survive reverting the box each and every time. So let me do just a thing to confirm that the box is still alive. Sorry about that. Yeah, it seems like everything is working as expected. It got the binary. So why are things hanging? Okay, theme seems to be hanging a lot. Let me get another shell. Now, copy selection. So let me come down here, try to log in again on the system. Let's just give it a second and see if it's going to work. Okay, let me see if my SSH is working. Yeah, it seems to be working as expected. Okay, it seems like I might have dropped the connection. Let me restart the box one last time. If it doesn't work, what I'll do is do, everything the way to, I'll just, let me say I'll go to the point where exactly how you're supposed to exploit the box. I want to do some bit of enumeration, but it seems like things are actually refusing to work. I don't know why. So let me restart the box one last time. Then probably just do it the way it was intended. It's like I won't do any enumeration because of time and because the server doesn't look to be, cooperating with us. So what you're supposed to do for previous was exploit this vulnerability. So what was supposed to happen was, remember we found this exploit, but there's no way we could have used it. Remember we found the directory traversal initially, but if you could have tried to read this file, you wouldn't have gotten the results. So this could have been a dead end. But right now, remember we have access to the system, so we can actually read this file. So the next thing that I'm going to do is to try to first of all, log into the system one last time and hope it works. So let me see if it's going to work. There it is. Then let me just try to cut this file. Okay, I didn't copy the file. Let me copy that file, then try to run it again and see if it's going to work. So here's the file that you need to read. So let me copy it right now. Come back here, do that. Then instead of using cut, I think it won't work. It will say command not found. So let me use type. And as you can see, we can actually read that file. Remember, initially what happened was we said that this specific, remember it's still Anger's version 4, that, it's the same version as the directory traversal one, meaning ours will actually be vulnerable. It said that it had this specific weak password encryption vulnerability. And it said that if we had the password hash, what we could do is we could actually try to decrypt that specific hash. So to do it, let's just try to look at the file, and you can see we have two passwords. So we have this one here, which appears to be a password 1 hash, and we have a password. Let me go up again. We have, it appears to be a password hash for the user administrator. So here it is, and it's something that you can actually read. So maybe you can try to decrypt that hash and try to see if you can actually log in as the admin user. So let me go down to see, we have password 1, which appears to be a hash. Then yeah, I think it's just that. Let's try to see if we can actually use it. So give me a second. Then what we can do is go back to a new tab, which here it is. Then what we can do is take this exploit, here it is, or even download it. So to download it, it's really simple. You can even just copy it. It says that the exploit was copied. Then do a vim, then exploit.py, and then do a set paste. So I think I already have done. I remember I did this box before, so I had already downloaded it. So let me just do a rem exploit.py, then vim exploit.py, then do a set paste to paste it. Here it is. Then there it is. It's good I didn't run it. Don't remember, the next thing that we need to do is to get the password hash for the administrator user. So let me just copy it. There it is. Then the next thing that I'm going to do is to come back here, then try to replace it to see if it's going to work. So just give me a second. So here it is. So let's try to run it. Python 3, then exploit.py. It says that the password is I am watching you. Let's try to see if it's going to work. And the reason I say I've known it is because if you just read the last character. So let me just, I think I have a folder called temp, if I'm not wrong. I don't have it. So vim vim tmp, then do a set paste. So here is the file. Then what you can do is to cut tmp, then do an awk, because we want to extract whatever we need. So we need to extract colon, then do a $print, then $2, because we want to get the last character only. So there it is. Then I'm going to do an output record separator to put it as nothing, so that I get everything in one line. So here it is. This is the password I am watching you. So the next thing that you can try to do is to try to again to use crack map exec, then SMB, then specify user administrator, then specify the password, which is I'm watching you, then specify the IP address. So let me just copy it from my second screen, then paste it here and see if it's going to work. So it says that that password didn't work. Let's go back to the following file and see if there's another password. I think there should be two. The last time we did the box, we had 2 passwords. So there is this password one. They think there should be another password. I don't know exactly why I'm not seeing it, but there should be a second password. I know because I've done this box before. So what I can do is, let me try one last time. And it seems like my connection closed. Okay, it works. So let me do a type. Okay, then try it again and see if we can get a second password. So as you can see right now, we have 2 passwords. There's another password that starts with an EC. So we didn't get this password before. That's why I'm telling that sometimes these tools might be finicky. So the best thing that I could have actually recommended is you actually going and downloading the file manually and to your box, then reviewing it from your box. It's actually a better approach. So the next thing that you're going to do is to go back to our exploit, then replace this hash with the new one that we got. So here it is. Let me try to see if I can actually do it fast. So there it is. Then try to run the exploit again. So Python 3 exploit.py, we get another password. So here it is. But as you can see, it wasn't able to decrypt the last password. So we have the password, but not the last digit of the password. And we're going to see how we can actually, be able to exploit that. But first of all, let's just run exploit.py, then pipe the output to temp again as we did before. Instead of doing that, because what it's going to do, it's going to output everything, including this banner. So let me just rm temp, then come back here, copy the save this one, then do a vim temp, then do a set dash paste, then paste everything in, then do an output record separator as we did before. So here it is. So we have the password, but it doesn't have the last digit, because if you look at this exploit again, the creator of this exploit didn't include every word. So there are some words and special characters that are actually missing from the exploit. So what you're going to do is we have a potential password for the admin user except the last digit that we can actually brute force. So to do it, it's really simple. What I'm going to do is to take the words that you already have, go to my Windows. So what you can actually do is to create a new file, then do what we want to do is to create a Python exploit. Then I'm going to do a shebang to tell it that. So it's going to be bin and then let me just say user bin and then Python 3. Then what we need is just strings. String. Then the next thing we're going to do is to specify a function, def root. Then here it is. I'm sure there's a session of Python exploitation that is coming up if you're going to go through it, so you don't have to worry so much about exactly what I'm doing. So let me just say exploit root as the word. Then the next thing I'm going to say if underscore name underscore equals, just need to put underscore main underscore, and these need to be 2 equals sign. So the good thing about coding with an ID, it gives you this errors. So I'm just going to be putting brute. Okay, brute, there it is. This is the function that I'm trying to call. Then I'm going to say cars, which is character is equals to be string dot printables. Then I'm going to tell the program to cut the last 6 characters. Then I'm going to be doing for car in cars. There it is. I need it to do possible underscore pass forward equals. Then I'm going to be doing an f string, then putting the string, then telling it that I need to include the car. So there it is. Then I'm going to be running this tool called Apple so that you can actually see exactly what I'm doing. So the next thing that I'm going to do is simple to just do a print statement to tell it that I want you to print whatever possible passwords. So as you can see, what the exploit did is that it took every letter from strings, then put it. It's like, you know, the last character now it's a 7, it's a 8. So till there it works. The next that I need to do is to save this output to a file, and to do that I'm going to be using the word with. Then with open, then specify a word, a file that I'm going to write into that is going to be called password.txt, then specify it as append, then as file, then do a file. Okay, seem to be having a file is not defined. I think that's okay. File.write, then specify car, no, possible. Let me just copy this. I think I'm having, okay, sometimes these are just some of the bugs that Visual Studio sometimes has that I don't think I want to debug right now. Then do a file.close to actually close everything. So with open, passwords, append as file, file.write, file.close. The exploit seems okay. So let me come back to my Windows and create pass.py. Then what we're going to do is to set as paste, then paste the exploit. So here's the exploit that we wrote. Then what I'm going to do is to run Python 3, then pass.py. So it didn't error out, probably because it worked. If I cut pass.txt, passwords.txt, you can actually see that it wrote, but I can already see an error. So this is why you actually run your exploit. And the error comes in because whatever I'm actually appending to the box, let me just do this again. Okay, then I'm going to append a new line at the end. So what I'm going to do is to write a password, then append a new line. So there it is. So let me rm passwords.txt, then run the exploit again. Then if I cut passwords right now, I think it should be 1 password per line. So there it is, it worked. So we are going to run crackmap exactly the second time, but instead of specifying the first password that we got, we're going to specify the password file that we actually have. So here it is. We're going to finish it in the next few seconds because what is remaining is really simple. It's just performing a brute force. So right now what I'm actually doing is performing a brute force using a crackmap exec. So I could have also done a brute force using SSH, because remember SSH was actually running on the box. But you might be asking exactly why didn't I do that? It's because if you did this box previously, you could have actually identified that SSH has a brute force lockout policy. So basically, if I brute force a lot of password, I could be blocked out of SSH. It's something that I identified after doing the box because I was actually blocked out. That's why I decided to do a brute force using SMB. It's taking a while to run, but I hope it's going to finish soon. So let's just give it a second and see if you're going to get the password for the administrator user. So let's just leave it to run through the word list. It's going to finish in the next few seconds. Then we're just going to get the password, then try to log in. But you know, I haven't gone through proper enumeration whenever you're trying to do a privilege escalation on a box. So while it runs, what we can do is let me go to online, then refer you to resources that you can actually look at one of the resources in payload, all the things, then specify, it's just going to go to GitHub because it's the first results. So here it is. If you go to methodology and resources, actually, this is one of the best, even while I'm doing my normal day work, as an engineer, this is one of the best resources that I actually use for pen test. So there is a folder called methods and methodology and resources. So let's go to it. Then if you go down here, it says Windows previous. So you can actually try to use this. It just gives you some pointers that you can actually try to, look at whenever you're trying to look at privilege escalations. Like it tells you that you need to run this tool, run this tool, run this tool, run this tool, run this. So these are some of the tools that you can actually run whenever you're trying to identify privilege escalation vectors. So you'll find really good tools like WinPeace, the one that I was trying to run, but demo goals were not on my side. So let's go back to see if it had been able to identify. As you can see, it was able to identify the password for the admin user. It's this one, watch 14 watchdog, then a dollar sign at the end. So given the fact that it says that the system is pawned, we can actually either log in via SSH. That's method number one. So let me just show both methods. I think it's better for somebody that doesn't know how to use both methods. So let's just try to log in as an administrator. Then you're not going to be using the keys that we created earlier. So let me just copy the password and hope it works. So here it is. So, okay, let me try again. Let me see if the password is correct. Okay, this one didn't work. And this is new to me, trust me, I expected it to work. But given it doesn't work, because I didn't try this initially, I got through a different way, but I'm assuming right now that doesn't work. Okay, that appears to be a dead end. But the next thing is, remember we have these pawn sign. So if we did let me just do the same exact thing, but this time include the actual password for the user, then do a -- shares. So there it is. Let's try to see if you're going to get the shares. So let's give it a second. It's going to say pawned, which means it worked. Then let's look at the shares. Shares, those are the SMB shares, to see if you're going to get anything interesting. You can see we have read-write access to both admin and C. If you have these read-write in both admin and C, you can actually start a service as the NT authority system user. So to do that, I'm going to be using a tool called InPacket, which is one of my best tools whenever I'm testing Active Directory environment. That's another session on Windows exploitation, but I'm not going to be talking about that today. So you're going to be using InPacket PS exec, and you just specify the following command, which is InPacket PS exec dash to specify the domain, because you're actually not logging to a domain control or any domain joint machine. Then specify the username, which is administrator. Remember, these passwords belong to the administrator user. Then colon the password, which is here. So here is the password, then at the IP address of the system. So let's just run the command and give it a second and see if it's going to work. If it doesn't work, we'll just try it a second time, but let's hope it works. So there it is. It's been able to upload the created binary, then it's creating a shell, and voila. So if I do who am I right now, we'll see that we have NT authority / system. So who am I? There it is. So we are basically even have higher privileges as even compared to administrators on that specific book. So if we go to /users /administrator, then /desktop, okay, /desktop, then do a dir. We can see we have the last flag for the box, so proof.txt. So let's do a type, then specify the proof flag, and there it is. So basically, this is how you could have done the box, for a CTF. But this is never the end. The fact that you've been able to get admin privileges on a site, the next portion is trying to see if you can try to use this box to perform a pivoting. So pivoting is where it's like you try to extract as many credentials as possible and try to perform login to other boxes. So one of the best commands is called InPacket secrets dump. Then it uses the same exact arguments. You don't have to add anything. Let me just say that that's the beauty of, I think it's correct. That's the beauty of InPacket, whereby if you understand how one command works, you can actually replay it in every other commands. So it is. So let's just give it a second to see if it's going to run. We get the target bootcamp. Let's try to see if you can extract the NTLM hashes for administrator, and even the viewer user. So while that is running, I think it's going to take about 1 to 2 minutes. Maybe Karim, I can say that this is this is the end of the walkthrough. We've been able to see how we can actually exploit a web application. Then from there, perform a privilege escalation. Then from there, do a post-exploitation. Let me say some sort of assessment of that box, because right now, given the fact that we found these hashes, we can actually try to log in into other adjacent or even other systems if we had access to, we could try to pass, using a technique known as pass the hash to try and see if we could have actually logged into the system. But this is the end of my walkthrough. These are the hashes you can even try to. Okay, so given the fact that we've been able to identify their password for the administrator user, instead of just logging into the system, you can try to dump the registry, the one that contains the sum on the system. Because if you do that, you'll actually get the hashes for these specific accounts. So I'm just going to be using another script from a bucket called secret dump. If there's an advice I can give you is if you're trying to exploit any domain controller, this is one of the best tools out there. You'll find there are tools like Rubias, tools like Bloodhound, but this is one of the best tools that you can actually find out there. So if it's something that you can actually use, understand exactly how it works, you can actually use it to exploit the box. But as you can see, it doesn't work. Reason being is my connection dropped for a second, so I need to restart the box, but I'm not going to do that right now. So I ran it earlier, like some few seconds ago before my connection dropped, and this is the output that it actually gave, whereby we were able to dump the NTLM hashes for the user administrator, the user gets, though this account is disabled, then the NTLM hash for the user viewer. So basically, you can try to pass these hashes to other systems if you had access to other systems to see if actually these credentials could work. If this was a domain joint box, probably it could log into every box using these hash if the user had access and privileges to log into that system. But basically, yeah, that is it for the walkthrough. These are just some post-exploitation techniques that you can actually use. They're actually really fundamental whenever you're trying to do an active penetration testing against an organization. So basically, these are the same things that you're actually going to use, either trying to crack the hashes, because you can pass them through either Hashcat or John the Ripper, or even some online hash cracking sites like CrackStation. It should actually work. Then try to see if you can actually get access to the system. But yeah, that is it for me. That is it for the walkthrough. I've given you already materials to go and look at privilege escalation. I can't look at it right now because of time. But if we get another session another time, God willing, it's something that you can actually go through the entire enumeration process. So that's number one. The second thing, I didn't go through this tool called Sliver in depth, but I'm telling you that it's one of the most amazing tools I've actually met out there. The reason as to why I can't recommend you to download the cracked version of Cobalt Strike, because most of the time it contains malware. So you can download it at your own risk. If you feel you're okay with it, then do so. But these C2 called Silver enumerates mostly, almost all functionalities that Cobalt Strike has. That's why, if you can actually learn how it works, it will actually help you in your engagement and pen test a lot. But I believe that's it for me. I'm going to hand the session back to Karim, for anything else that maybe you'd like to add.
Yes, thank you very much, Ian, for just taking your time to take us through the session. So there are some few questions for you, actually two to be specific. So the first one is, where can we learn how to do Windows exploitation?
So, the best thing that I can tell you concerning Windows exploitation is that boxes can actually build your capacity in terms of understanding exactly how exploitation works. Remember, let me just say, I've just covered the tip of an iceberg. That's the best one, the tip of an iceberg. But the thing is, if you go to platforms like Hack the Box has a lot of Windows machines. If you want to learn Windows exploitation, it's one of the best places that you can actually learn it. So that's number one. The second thing is, if even while I was preparing for this session, I had another box in mind that was on Hack the Box, but it's one of, let me say, complicated box because it's an active directory domain controller. So that's why I just decided to try something simpler, but Hack the Box. I'm sure if not all of you, most of you have heard of Hack the Box. It's one of the best platforms. It's where I started learning. The next platform is TryHackMe. But I think I said it previously that, in the last session, that if you're a complete beginner, I'd recommend you start from TryAcme, then go to Hack the Box, because Hack the Box has real world systems. So it will actually be a bit more overwhelming if you're a total beginner. If it's something you can try, there are even, I think it's called, I can't remember the name, but it has this section like Academy that you can actually learn everything, but TryAcme is actually better for beginners. But the moment you start feeling that you're getting advanced, Hack the Box is one of the best environments that you can actually use to learn Windows exploitation. There are also articles, tools out there that you can actually try to look at. One of them is the payload of the things repository that I actually shared a few minutes ago during the walkthrough. So go through it. It will give you, some insight on exactly what you can look at whenever you're trying to exploit Hack the Box. Not Hack the Box, but Windows in particular. Also, as I said, different servers, different systems will have different ports open. So understanding how every protocol in Windows works, it will be another advantage, because it means that you'll be in a position to actually exploit that system. And one of the best places is Hacktricks. Hacktricks contains how to exploit most protocols on any system. So Hacktricks, look at Hacktricks, look at payload other things, look at TryAcme, look at Hack the Box, and by extension, any article or any sort of information that you can actually find out there. I can say that what I usually used to do when I was a beginner was I didn't filter out any information. So long as I could consume any information that I could find in the web, so long as it's concerning hacking, definitely I could consume it. So whatever whatever articles, documents that you can get concerning exploitation of Windows out there, try to consume them as much as possible, because trust me, one of these days you can actually get it in a real engagement. Yeah, that's it, Karim.
Okay, the last question will be, how can I learn all the techniques that you have demonstrated, and where can I learn it? So it's how and where.
The same.
How and where.
So how is what I can say is I'm still learning, but the thing is, it's like you learn by practice. So
yes,
the good thing about InfoSec is the more you do, the more you get better. I know there's theory like compliance and risk, but if you're trying to be an hacker, somebody that is on the keyboard all the time, it's something that you have to do it practically, because you understand by doing something practically. So the best thing is, I believe it's like still the same platform applies. If you want to learn techniques, pick a box, go to Sliver, try to see, can I be able to exploit this box using Sliver? Like get a shell, then use Sliver to get and remote code execution, an interactive shell. Try to see, how can I use the different extensions of Sliver? By doing that, you'll find that you learn all these techniques. Like right now as we speak, most of you can't just generate a payload from MSF Venom from Metasploit, then run it on a Windows box, because definitely Defender is going to capture it. So the thing is, it's like, how do I put it is, taking a system, then it's like going to MSF Venom, trying to see, I have this payload, it gets detected by Defender each and every time. Is there a way I can do it? Can I try to encode it, to encrypt it? That's another technique. That's how you learn, by actually doing it. Or you can just decide, I'm not going to be using that payload. What I'm going to be doing is to go to create a C# reverse shell, then from there implant a shell code, then from there encrypt whatever I need to encrypt using XOR to ensure that Defender doesn't capture it, then executing it and hoping for the best. If it doesn't work, take that payload that you've generated, then do another encryption using some C# encryptor, then hope it works. So basically, I'm saying that the best way to learn whatever techniques I've said is by doing practice. You can actually read books, that's okay, but if you don't practice it in some time, you'll actually forget it. So I feel like practice is the best way. That's what I'm saying. I recommend you try to, if you don't have an account to register for TryAcme, register for Hack the Box. If there are CTFs in your area, try to do them as much as you can, because that is where you're actually going to get the knowledge that I have. I'm still learning even. By the way, I'm not the best out there, but I'm actually trying to learn as much as I can so that I can actually be one of the best out there. Cybersecurity is more about learning each day. There is no day you would say that I've reached the end of learning whenever it comes to cybersecurity, because I want you to know this, that in each and every new day, new vulnerabilities get identified, new techniques of exploiting system gets identified.
Yeah.
So it's up to you to understand that you need to keep on learning, to keep on improving, and to keep on becoming better. That's how you're going to be exactly how I am, and even you can even become better than I am, because as I've said before, I'm not the best. I'm still even in that learning process.
Yes, thank you very much, Mr. Ian. We understand you're trying your level best to be humble, but we already know that you're the best. So thank you very much for taking your time to take us through this session and just clearing up your schedule to be with us here today. So thank you very much, Ian, and you have a good evening.
Most welcome. You too have a good evening.
Okay, cheers. Bye-bye. Thank you.
Thank you.